Excellent. And I am live. For those of you that are live right now, so I do have people in the chat, I'm going to be asking for those notebooks to be out and open because I got no time to waste. I got less than a 60-minute class period to get all the information out that I need. Oh, less than 60. Yeah. It's exactly 60 minutes, but I just spent the first 2 minutes explaining. Yes. Let's see what we got here. I would remind all of you that there is a Desmos activity that is due by 2 o'clock today. I need this Desmos activity done, even though we're not going to be severely discussing what's on this Desmos activity today. I need that done because it's going to inform a lot of the future lessons that we end up doing in this class. So let's start off right here. Now I'm going to call this solving polynomials. Solving polynomials. Last week, we started off talking about polynomials and what is involved with polynomials. Today is the 17th. So let's start off with a very basic example that I'm going to show you on a few graphing things. Let's talk about f of x equals x cubed plus 9x squared plus 26x plus 24. The pace of today is going to be very deliberate. I am going to stick with the same example for a little while. I am going to stick with this example for a little while because I really need to emphasize certain things. I am going to have you recopy and redo certain things over and over again in order to emphasize certain points as to what it is that you have to do in order to succeed in this chapter. Now, what I have on the board right now is a cubic equation. This is a third-degree polynomial. A third-degree polynomial in the sense, well, the largest exponent is a 3. Okay. Typically, these polynomials are going to be written with the largest exponent all the way down, second largest, third largest, etc. This is what shape they'll typically take. Let me show you what it looks like in a graphing calculator. Now, in a graphing calculator, I am going to show you this on Desmos as well. But in a graphing calculator, which is what you have, which again, you don't have to have them out right now because I'm going to show you everything here. You would simply type that thing into your y equals key, and you would graph and hope for the best. Oh, let me change the size of that window. There we go. You'd graph it and hope for the best. This is what we get. It's got this kind of weirdish shape to it. What? At this time, any remaining seniors who have not been counting down orders, you may come down now. Okay. This is the basic shape that a lot of cubic equations are going to take. If I can actually come up and change, kind of emphasize what's going on here. This thing kind of goes up, and then it comes back down a little bit, and then it goes up, like that. Seemingly, this graph crosses the x-axis 3 times, thrice. Can you tell me, or can you guess where? This polynomial crosses the x-axis 3 times. Can you guess where? What value or what x-intercept value do you think it is? Looks like 3 different ones. Guess one of them. 2 would be over here. -2. Could be -2. It could be. I don't know for sure right now, but it could be. It definitely could be. What else? Looks like so -1, -2, so negative 4. It looks like -4. And then the one in the middle, can I guess what, -3? It looks like it. If this were a guessing game, yeah, we could guess -2, -3, -4. Maybe. Are we guaranteed? No, we're not guaranteed. But you're going to have to prove it. You're going to have to prove it. Let's take a look at Desmos real quick. Let's take a look at this thing on Desmos. Now, you have graphing calculators, of course. But Desmos is much easier to kind of deal with as time goes on. Let's take a look at this thing. So this plus 9x squared plus 26x plus 24. There's that thing right there on Desmos. Now on Desmos, you could zoom in a lot easier just by using the scroll wheel. And on Desmos, you can actually click on those things, which is nice. You can actually click on those things on Desmos, which is super convenient. I would highly suggest that if you're going to do anything with Desmos, like do it. Like it's fantastic, really. But again, this would not be sufficient if it were one of my assessments. Can't just be like, well, Desmos told me. The calculator told me. Nope. We're going to have to prove it. We are going to have to prove it. And here's how we're going to have to. Here's how we're going to go about it. What I'm going to do. Come on, zoom in, little thing. There we go. What I'm going to do is what we started last week. What we started last week was this synthetic bar. And I'm going to put some numbers in here. First, I'm going to put these numbers on the inside. Where did those numbers come from? Say again? Coefficients. That was the word I was looking for, yes. They are the coefficients of that equation. The coefficients are the numbers directly in front of the variables. It's a 1x cubed, a 9x squared, a 26x, and a 24. Those are the numbers that I need. And the number that goes on the outside is what number we are guessing to see if it works. Now, you said -2. Let's just guess -2. We think -2 is a, quote, 0, end quote. We think -2 is a 0. Whatever number we think is the 0, the number that we are going to plug in is going to be the number that you put on the outside of that bar. Once we run through this synthetic bar, we will end up knowing whether or not we were correct. Right now, no idea, but we will in a few minutes. Now, I want to remind you as to how this bar works. Some of you already know how this bar works. Some of you already know, number one, how this bar works, and some of you could probably run through this entire synthetic bar right now. Good for you. Great. But for those that don't, let me kind of walk you through it. This bar is performed with repeated addition and multiplication. Addition and multiplication. Addition and multiplication. It goes back and forth until you get down to this bottom right number. That is how this bar works. It is nothing more than adding straight up and down and then multiplying by the number on the outside. And again, like I said, some of you have probably, I know for a fact, some of you probably have already gone through this right now in the past like 5 seconds. Good for you. Great. 1 plus nothing is 1. That was boring. That number always comes straight down. But then I got to multiply. Multiply by -2. All right. And I get -2. Notice where I just put it. I just put it in the first blank spot. Now I repeat. Now I add vertically. Now I repeat. Now I multiply by the -2. I get -14. If I'm correct, if I'm right, what number should I get here? I should get a 0. If I'm right. I think we're right. But let's just see what happens. I'm going to add vertically. and I get a 12. I'm going to multiply by that negative 2 again. I'm going to add vertically, and yes, indeed, we get a 0. That 0 means everything right now. That 0 does so many different things. First of all, that 0 proves negative 2 is a, quote, 0. End quote. It proves it. It proves it. Over here, we didn't know whether or not negative 2 was a 0 yet. We think negative 2 is a 0. But then when you plug it into the synthetic bar, into the synthetic substitution, and you get this result down at the bottom, this now proves that negative 2 is a 0. You have to be able to prove things. Not only does it prove that negative 2 is a 0, it shows you that f of negative 2 is equal to 0. That's a definition that we wrote down last time. And it proves, and I'll write the definition on the board in a moment, but it actually proves that x plus 2 is a factor. It proves that x plus 2 is a factor. The exact definition that we had last week was basically if f of k is equal to 0, then x minus k is a factor. This is going to play a big role today. It's going to play a big role today. That's the definition that we wrote down last week. And again, notice it's x minus k. In this case, it would be x minus negative 2, which would give you plus 2. Please be aware of that. There's so many things that this thing does. Getting that 0 does all those things. Question or stretching? All right, just making sure. Just making sure. Getting that 0 means so many things. It proves it's a 0. It proves it's a factor. It shows you the input-output f of x notation. It does more. It does more. Now I'm going to go into the details in a little bit. But these numbers right here, these numbers actually show the result of division. It actually shows the result of division. I can spell the word division today. Division. There we go. It shows the result of division. This bar means everything, especially for what we're doing over the course of this chapter. Over the course of this chapter, this is going to develop into something very important. Let me deep dive this a little bit more. This is the great thing about having you guys back 5 days a week. I can actually take the time to deep dive and explain these things, which is oh so great. So let's actually do that. Parentheses. X cubed plus 9x squared plus 26x plus 24. Mr. Markey, that's the same exact equation. I know it's the same exact equation. I want you to write it down again. Divided by x plus 2. Move this over just a tiny bit. This is actually what we just did. This is actually what we just did with this problem. It is amazing. We have actually taken this original polynomial and we have divided it by the factor x plus 2. That division, that act of dividing this polynomial is shown here with these 3 numbers. It is the result of division. They are exactly what we need. Now, just for the sake of argument, when you guys divide things and you have something left over, what do you usually call it? A remainder. That's your remainder. That is your remainder. That number right there that I'm pointing to. The last number on the bottom right is your remainder. From last week, do you guys remember what this was? This is last week's stuff. If this number is your remainder, and then you move over, what's this? Your constant, your next one, your x term, your x squared term. Yeah, that's the result of the division. That is the result of the division. The 1, the 7, and the 12 actually make up a 1x squared plus 7x plus 12. You actually multiplied, or I'm sorry, divided, I should say. You actually divided two polynomials. Insane. Now, the thing is, if I gave you this original problem, let me zoom out a little bit and kind of scroll this down a little. If I gave you this original problem on a test or an assessment, whatever it may end up being, this original problem, I may say to you any number of things. I may say, hey, solve it. Hey, factor it. Hey, graph it. I may say any number of things. But it doesn't matter what I ask. Because what you are going to do, regardless of what I ask, is you are going to break that polynomial down into its prime factors. You have to. Whether you're graphing, solving, or factoring, you're going to have to break it down into its prime factors. So far, we found one factor. We found one factor. The factor that we have found, well, -2 is not the factor. X plus 2 was the factor. -2 was the 0. Big difference. But we got to keep going. So far, we found one factor. And we divided it right here. We divided it right there. At this point, you have options. Let me give you a bullet point here. Bullet point. Once you reduce the equation to a quadratic, you have options. We have taken this cubic, this third degree polynomial, and we have divided out a factor, leaving you with a quadratic, something we've been doing since the beginning of the year. Once you reduce the equation to a quadratic, fix that Q there, there we go, you have options. Option number 1, you can continue synthetic with the quadratic, which is actually what I'm going to do when we get there. Option number 1, you can continue synthetic division with that quadratic. That's option 1. Option 2, you can factor that quadratic. Now, I taught you the Tucker method. You may know a different method. I don't even know what that some people use like a weird kind of X thing. Cool, whatever. But you could factor that quadratic. Factoring that quadratic will get the remaining factors. Or option 3, the quad formula. You don't have to do all 3, but you may be forced to do one over another. Synthetic division will only work as long as you know what numbers to plug in. Factoring will only work if you actually can factor it, if it actually is factorable. The quad formula will always work. The quad formula will always work. Please keep that in mind. Now, I have some very basic examples for you today in which we may not have to use the quad formula. But I want you to get used to this. You have options. You choose what you need to do. You guys know who Encyclopedia Brown is? Anybody? Encyclopedia Brown was like, they had, okay. Do you guys know Babysitter's Club? Okay, some of the girls are nodding yes to Babysitter's Club. All right. Babysitter's Club is like these like little short books written for like young girls in elementary school. I don't know. Netflix actually made a miniseries, or not a miniseries, but like a show out of it. Whatever. Encyclopedia Brown was like the boy version, except it was like a choose your own adventure mystery novel. Whatever. You're the weird ones. I want you to write this down again. This is the third time I'm having you write it down, but I'm doing it for a reason. Write it down one more time. The same exact equation that we have been working with. I want to pretend for a moment. That we're starting this problem afresh because I'm not done with it. Let's say that I gave you the following directions. I would say, hey, factor it completely. Find all zeros. Those would be the directions that I give you on an assessment. I would say, hey, factor this completely. Show me all of that work and find me all of the zeros. Well, we found one of the zeros so far. We already know what that zero is. Let's do it again. 1, 9, 26, 24. We found -2. I want to do this one again. Watch how quick this can be. If you know how to actually do this thing properly and quickly, you can knock out this synthetic bar pretty nicely. That's a 2. So now, I want to emphasize the fact that this was our remainder. Tell me. If you don't get a 0, what 2 things could possibly have happened? If you don't get a 0 here, what 2 possible outcomes are there? Huh? The number that you plugged in wasn't one of the zeros. That's one possibility. What's the second possibility? You made a mistake. That's the second possibility. Absolutely. So just to be aware, if you don't get a 0 here, one of 2 options. Either you made a mistake or the number that you plugged in was wrong. This number. So you always have to double check for every possibility. You always have to double check. If you get a 0, then, hey, you did it. Well, let's see what happens now. This results in the 1x squared plus 7x plus 12. So let's continue the synthetic division using those brand new numbers. Look what's written there. We're going to continue the synthetic division with those brand new numbers. Let me take a look back at Desmos real quick. I'm going to flip back to Desmos real quick. Boom! -4. -4 was the next number that you guys told me. -4 was the next one that you thought, hey, that one looks like a 0. -4. That's a possible 0 right there. Okay, let's see if it works. 1 plus nothing is 1. Multiply by -4. 7 plus -4 is 3. 3 times -4 is -12. Add those together, I'm going to get a 0. This number, again, is your remainder. Look at the number that I'm pointing to. I'm going to move this up a little bit. Look at the number that I'm pointing to. If the 0 is your remainder, then what's this number? Constant. The next one, x. That's a 1x plus 3. That is a 1x plus 3. Now, what does that mean for us? Again, you have options at this point. That is really a 1x plus 3. At this point, you could legitimately just solve that. That's your remaining factor. That is your remaining factor. You could legitimately just set it equal to 0 and solve. What's the remaining 0? What's the only 0 we haven't gotten yet? -3. And if you solved that, you would get -3. That's what this thing... Now, if you wanted to be weird about it, you could do this, which I'm just writing down for funsies. 1, -3, 0. Yay, I did it! What have we proven? We have proven that, and you're writing this down, of course, -2, -4, and -3 are zeros. Hold on.
At this time, any juniors that we should purchase rings can come down in the main lobby. That's juniors for ring purchases. Thank you.
Juniors for ring purchases. Okay, cool. This also proves x plus 2, x plus 4, x plus 3 are factors. By doing this synthetic division, by showing that the synthetic bar results in a 0, you prove the zeros of the function, and you also prove the factors. You prove the factors. Let's do another example. A different example. This is actually now the second example we're doing today. Brand new problem. We're going to have to look at a graph. We're going to have to identify some new stuff. But this is the brand new problem that I want to deal with. (3x cubed minus 8x squared minus 5x plus 6). I'm going to have to put that into my calculator. Let's see what it looks like in the calculator. Hold on. 3x cubed minus 8x squared minus 5x plus 6. You guys know how in the graphing calculator you have a square button? You guys know that, right? You have a square button on the calculator. Did you know you have a cube button as well? Some people are nodding yes. Check it out. When I say you have a cube button, look at this. Now, yes, I did do 3x raised to the third power using the caret symbol. But if you hit the math button, the third option right there is actually your cube. You actually do have a cube in there, which is nice. But regardless, I'm looking here. All right, let's make sure I got that written down correctly. Yes, minus, minus, plus. There we go. Let's graph it. Graph! Shazoom, shazoom, shazoom. Okay. What the heck just happened here? First of all, okay, they're going to interrupt. Come on.
If you are a Waretown or Toms River student, you will be on bus 25 today. Waretown and Toms River students look for bus 25.
The equation? Oh, look at the top of the screen right there. There we go. This thing does a lot of junk. It actually goes below the screen right there and fires back up right there. This is what the graph actually does. This is what the graph actually does. It crosses the x-axis 3 times. 3 times. Nice. Can you tell me where? Can you guess where it crosses the x axis. Looks like -1. I'm not too certain about that. I'll type in 0.75 in a minute, but what's the third one? Looks like a 3, yeah. Those two I would agree. Those two I would totally agree. Check this out. 0.75. Unfortunately, 0.75 is not the x-intercept. Yeah, so that's what I'm saying. In order for the 0.75 to be a 0, the y value would have to be 0. But it doesn't work. Ooh. Is it? We can keep guessing all day long. Here's the thing. Can we agree that it's somewhere between 0 and 1? Okay. It's not. You don't have to guess it right now. Because here's the thing. There are 3 zeros. And because there are 3 zeros, and we know 2 of them, we can use synthetic division to divide out 2 of them. And when we divide out 2 of them, whatever's left over will give us that third number. It'll give us the exact number. Now, I don't know what number that is. It could be 0.5. It could be 0.75. It could be 0.6 repeating. It could be 0.7312. I have no stinking clue. I don't know. I'm a poet that wasn't aware of his circumstances, instead of a poet who didn't know it. Anyway, let's go back to here. So we think +3 is a 0. So let's do it. If you want to race me. Race me to the end of the synthetic division. I'm going to go at a deliberate speed, but you go faster than me. 3 plus nothing is 3. Multiply. Add. Multiply. Add. Multiply. Add. 3 is definitely a 0 of the function. Now look what we have left over. What we have left over is a 3x squared plus 1x minus 2. That's what we have left over. What was the other 0 that we thought it was? What was the other 0? We saw +3, but what was the other one? -1. And then the third one, we have no clue. But let's just see what happens. Let's try it with -1 then. Let's try it with -1. 3, 1, -2. Notice. I'm not going back to the beginning of the problem. I'm not going back to the original cubic. I'm done with the original cubic. What I'm worried about is what I have left over. What I have left over is this quadratic, based on the numbers from the previous synthetic division. This quadratic, I can divide out another one, another 0, and it will whittle this thing down. It'll whittle this thing down until I have nothing left but all of the things that I need, all of the zeros. It started out as a 3rd-degree cubic. I divided it down, and it became a 2nd-degree quadratic. We're going to do it one more time, and we're going to reduce it down to a 1st-degree linear. Let's see what happens. 3, multiply, add, multiply, add. Nailed it. You tell me, what equation do I have left over at the bottom of the screen? Close. 3x minus 2. Because it's weird. It's very weird. But you got to go like right to left. Remainder, constant, x. You got to go right to left. It's a little backwards. But yes. We have a 3x minus 2. And here's the thing. I'm done using synthetic because you could just solve this. Set it equal to 0. Add 2. Divide by 3. There's the exact number. I know you guessed 0.75 and you guessed 0.5. It was actually the decimal 2/3. Yeah. I know, isn't that weird? Watch. I'm going to zoom in on the graph. Check this out. Zoom in, zoom in, zoom in, zoom in, zoom in, zoom in, zoom in. Watch this, watch this, watch this. Trace 2/3. Now, when I hit enter, X won't say 2/3. X will say 0.6, repeating with like a 7 at the end. But look at the Y value. There it is. You could try to guess, and you might get it. You might get it if you guessed. You could. But the thing is, you don't have to guess. You don't have to guess. So, X equals 3, X equals -1. These are my zeros. They are the zeros of the function, and I have proven all of them. I have proven all of them. I proved the 3 and the -1 by synthetic division. We got the 0 at the end. I proved the 2/3 by solving what was left over, the 3x minus 2. I also have my factors. And this is also important because they may ask you to factor this thing. X minus 3, X plus 1, and 3x minus 2. That's not a typo. Remember, look at the definition that I have written in orange to the side of the board. Look at the definition that I have written in orange to the side of the board. If you have k as a 0 of the function, if f of k is 0, which we proved, 3, then x minus 3 is a factor. -1. Then x minus -1 is a factor, which is why it becomes +1. All of this stuff is interconnected. It is phenomenal. Ugh, those things have to save people's lives. Why are you desecrating them? I don't know. Okay. Let's try this. We're going to go deeper with a problem. Who in the what? Roughly plenty. We have roughly under 20 minutes. Yeah, can you believe it? I believe 10:28. Yes. Next example. Now, I'm going to have you try some of this in a moment. But this problem, I am going to focus a lot of our attention on for the remainder of this class period. I'm going to put this into my graphing calculator. I'm going to put this into Desmos so that you can start the problem. But I'm going to have you go as far as you possibly can on your own. I'm going to have you go as far as you possibly can on your own. And then I'm going to check to see where we're at. Because we got to see what's going on here. We're going to have to factor this thing, and we're going to have to solve this thing completely. First of all, let me type this into the y equals key. And then I'm going to put this into Desmos so we can get a better look at it. Okay, I'm just double checking to make sure I typed it in correctly. All right. I'll come back to the screen in a moment. Let me zoom in. Zoom in, zoom in, zoom in, zoom in. There is the equation. It'll focus. There it is. X to the 4th plus 3x cubed plus x squared minus 3x minus 2. Let's look at the graph. Look at that. Looks like the bottom of Florida, or a boot, or a really sad bird. Could be. I was thinking a bird, taking a head dive into the ground. Anyway, let's take a look at Desmos. Let's take a look at Desmos here. X to the 4th plus 3x to the third plus x squared minus 3x minus 2. There we go. Look at that. That's probably a better view of it. And of course, with the computers that you have, when you're doing my work, because I am going to be eventually assigning you work out of this, but when you do my work, of course, you have Desmos at your disposal. Don't forget the Desmos assignment that I have for you. But with this, it looks like we can identify some things. What the heck is going on here? Do y'all see that? What does it look like to you? It looks like an x-intercept. Be more specific. What does it look like? It looks like -1. Be more specific. If the graph hits an x-intercept, doesn't it typically go through? What is this one doing? It's like just touching it and then coming back. That's weird. That's weird. Okay. So here's what I want you to do. Take a few minutes. Try -2, -1, and +1 as the zeros of that function. I want you to divide them out. I want you to whittle this thing down. Each zero that you divide out should bring the polynomial down 1 degree. Right now, it's a 4th degree polynomial. You divide out one of those zeros, you're going to bring it down to a 3rd degree, then you're going to bring it down to a 2nd degree, then you're going to bring it down to a 1st degree. Take some time, knock it out. I'll give you a few minutes. My tennis ball. Someone save it. Okay, no. Yay. Yes. Back to the bed. Dude, pull this out from there real quick. Yep. What number is that? -2. Okay. Very good. That's a -1. -3 plus 2. Yes. That should work out. You have a lot of different options. A lot of different options for starting these problems, for maneuvering through these problems. You don't have to do it in any one specific order. I'm going to go in the order that I saw them on the graph. The order that I saw them were -2. I'll highlight them here. -2, -1, +1. That's the order in which I saw them. So I'm going to take this 4th degree polynomial. 1, 3, 1, -3, -2. And I'm going to put a -2 in there, just in the order left to right. Doesn't matter. 1, -2, 1, -2, -1, +2, -1, +2, 0. Now look what we've just done. You are whittling this thing down. Look where I'm pointing. This is your remainder, your constant, your x squared, and your x cubed. This is actually 1x cubed plus 1x squared minus x minus 1. That's the resulting equation. You have taken a 4th degree polynomial and you have reduced it to a cubic. Let me go back to Desmos real quick. Hold on, get rid of those. What's in red is our original problem. What's in red is our original problem. Now watch this. Cubed plus x squared minus x minus 1. Look what's going on here. Now look what's in blue. Blue is a completely different equation. Blue is a completely different equation. But look what happened here. It no longer, the blue equation doesn't go through -2. But the blue equation still just touches -1 and still goes through +1. It still does those things. Haha. It still has the same answers. It's just our job to keep whittling this thing down. It's just our job to keep whittling it down. Let's just see what happens. So, chapow. Let's keep going with it. Let's try the -1. 1, 1, -1, -1, with the -1 on the outside. It should work. 1, -1, 0, 0, -1, +1, 0. Interesting. This bottom right 0 proves that it works. You tell me, what the heck is going on here? Constant? What is that? But it was like, hold on, remainder, constant. What should this be? Should be my x, right? So it's like a 0x. You have to take that into account. It's a 0x. Technically. But then you got to make this an x squared. Yeah. This is really x squared minus 1. That's what the resulting equation actually is. Now again, if I go back here and type in now that green equation, look at the green equation. Still has that +2. Something's going on here, though. Something's going on with that -1. I thought we divided out the -1. Something's going on there. Let's talk about this. Now, the thing is, I have a quadratic. I have a quadratic right there, and I have options. One option is to continue with synthetic. I could. Or, because it's a quadratic, I could factor it. In fact, this factors into x minus 1, x plus 1. That's what it factors into. I could solve that. That's exactly what I'm going to do, though. I'm going to get x equals 1 and x equals negative 1. Wait a minute. Wait a minute. Wait a minute. No. Why do you think I messed up? Well, let me recap what we just did. Look at this. Watch where I'm going to point now. Watch where I'm going to point now. Ready? Ladies and gentlemen, watch where I'm going to point now. Right here. Earlier, I proved that negative 2 was 0. Then, we proved that negative 1 was 0. Then, we proved that 1 and negative 1 are also zeros. Let me bring down the other zeros that I had earlier. What do you notice about these 4 zeros? What do you notice about these? Now, watch me. What do you notice about these 4 zeros? Ooh. Nah. Positive, negative has nothing to do with it. Let me come up here and do that finger quote thing again. I got 4 zeros, but visually, there's only 3 x-intercepts. Yeah. The negative 1 repeated. It repeated. Let me go back to Desmos real quick. Something happens here. See, the thing is, there is a very specific definition. A very specific definition when it comes to polynomials. And it has to do with these things. Hear me out now. It has to do with these things called turning points. A turning point is when a graph changes its vertical direction. How many turning points are in this graph? When it changes its vertical direction. Vertical direction. So it's going down, then up. That's a turning point. Then down, that's 2. Then up, that's 3. There are 3 turning points. There are 3 turning points of this graph. There's a definition that talks about the minimum number of, or the maximum number of zeros that you could have. We found 4 zeros. But there's only 3 x-intercepts, like you said. That happens when a turning point occurs right at an x-intercept. It is what is known as a repeated zero. Now, a lot of those definitions and the definitions of turning points and all that stuff, I'm going to give you that stuff next time. All those definitions, because it's all going to be interconnected. It's going to be amazing. For me, it's going to be mainly amazing for me, not for you. Pay attention to Google Classroom. You need to get that Desmos activity done. Read the directions carefully on it. It is due today. Of course, I will be on Google Meets every 10-minute interval after school. Most ridiculous thing in the world, but it is what it is. Nothing I can really do about that. In the meantime, I'm going to sign off. Class ends in about 1 minute.